So today I am going to talk about the variational principle or the variational method which is used in quantum mechanics. So in quantum mechanics there are some Hamiltonian, and these Hamiltonian cannot be solved either exactly or perturbation theory, right? So they cannot be solved either for certain problems exactly or the perturbation theory. So to solve such problems we will use another method, and that method is known as variational method, or this method is known as Rayleigh method, right? So what do we do in this method? We will start with the trial wave function. We will start with the trial wave function. Trial wave function, and this wave function depends upon either one or more than one parameters, right? Mathematically I can say that psi is either depends upon one parameter, or it may also depend upon more than one parameter, psi alpha 1, alpha 2, and so on, alpha n, right? So this is how our wave function looks like. Now what do? We will find the value of these parameters, means we will find value of these parameters such that expectation value of energy is the lowest possible, right? That's what we are going to do in this method, right? And this is a very simple and very important method. So let us understand it mathematically. So here this is our Schrodinger wave equation, that at psi E psi, this is eigenvalue problem. Generally what do? We have to solve this equation, but in this method we are not going to solve this equation, means we are not going to solve this eigenvalue problem. We are not going to solve this eigenvalue problem. So we will start with the trial wave function. Let us start with the trial wave function. Psi, and psi depends upon some parameter, either depend upon one parameter or sometimes it may depend upon more than one parameters, right? So that's what we will choose, the psi here, and we will choose these parameters. Alpha or alpha 1, alpha 2, or alpha n are chosen such that the derivative of energy with respect to the parameter, or sometimes it can be written like this, or curly E psi over curly F1 is equal to 0, curly E psi over is equal to 0, and curly E psi over curly alpha n is must be equal to 0. And sometimes in some texts it can also be written like this: delta E psi, it must be equal to 0, right? So we have to choose those values of alpha for which this energy will be minimum, right? So here E psi is the expectation value of energy in the state psi, such that this energy E, expectation value of this energy E, it can be estimated using this, right? So this is our equation number 1. So let us write down a special note here, that is, for any arbitrary trial wave function, psi, we choose energy E, given by equation A is always larger than the exact energy or ground state energy, and let us call it as E naught. Therefore, using this note, we can write down this E is always equal to psi h psi over psi, means scalar product of psi here, and it is always greater than equal to E naught. Means also this inequality will become equality, means the equality condition occurs only when the psi is proportional to the true ground state, to the true ground state wave function, that is psi naught, right? So this is the mathematical description of this variational method. So this is all about today's lecture, and in the next lecture I will discuss an application of this variational method, and in that example we will try to find out the ground state energy of the hydrogen atom. So that's all for this lecture.